Hey, welcome, guys. How are we doing this Wednesday evening? Welcome to Revise for a Prize. So, we're going to do the same thing today. We're going to go through a topic. Today's going to be chemistry. We're going to do a quiz, a Kahoot quiz on it, and we're going to give the prizes to the top two places. It's going to be £25 for first place and £5 for second place. So, the topic we're going through today in chemistry is acids and metal extraction. So that's about 4 different sections on our website. So remember, if you want to see all the notes that we're going through today, then head on over to flashrevisionlab.com. Hello. Hi, Ashton. Hope you're doing well. So we got the Kahoot ready. Let me show you the Kahoot screen as well. You guys can join now if you want. Roy Akbari, hi, good to see you as well. The game pin is 7667776. Let me write it down here as well, so you guys, when people join, they can, if they join late, they can also add their names in. All right, guys. So put the pin in, create your nickname, and let's see who we got. We got Clever Gazelle. Let me know who you guys are. How long is this session? About an hour usually. I'll whiz through the topics, and then the quiz is going to be about 15 questions. So yeah, it's about half an hour. But it changes sometimes depending on how much I need to get through. Golden Crane, we've got 2 people in it. Debashri, don't worry, no worries. Good to see you again. Good to see you. With Golden Crane is TKD. Dennis, good to see you as well. Second place winner from last time. Let's see if you can get first place this time. So we've got 4 people in here. I'm sure that's going to increase as time goes on. Let's get started then. 5 people. All right, keep it going. And let's go through it. So which topic is this? So this is topic 4. So remember, on our website, we've got the whole of AQA chemistry, biology and physics summarized here, topic by topic, broken down in order of their spec points. So what we're doing today is part of chemical changes. So within chemical changes, you've got 3 main topics. We're going to go look at the top 2 here. I think electrolysis needs a whole session for that. That's a tricky one, right? What do you guys think of electrolysis? Let me know in the chat. Do you guys like it, or do you find it hard? My opinion, probably the hardest topic of chemistry paper 1. Chambers is in, good to see. What's the prize? So it's £25 Amazon voucher for first place and £5 Amazon voucher for second place. Debashri says it's kind of hard. You need to learn it for EdXL. Yes, you do need to know it for EdXL combined as well. I'm pretty sure all GCSE students need to know about electrolysis. It's one of those topics. Ooh, TKD loves electrolysis. That's I don't hear that much. So that's good if you love it, because I guarantee you about 90% of students don't like that. So what we're going to go through first is reactivity of metals, and then we're going to do a bit of the reactions of acids. So we're going to go through the reactivity series, very quick, extraction of metals, the difference between oxidation and reduction. Then we're going to look at the pH scale, differences between strong and weak acids. We're not going to look at the reaction of acids or required practical. So it's the top 5 topics here. Those are the ones that we're going to go through today. So let's pick our topic. So we're going to start with the reactivity series. So as usual, like I said, for each topic, we've broken it down into notes, questions, spec points, and a new feature here we got is flashcards as well. So for every topic, we've got those for you guys to look at. So reactivity series, very simple. What we have here is a reactivity series. It's not the reactivity series. You can have loads of different types of reactivity series. What we've got here, because this is based on the AQA spec, we've got the AQA reactivity series. So we've looked at the spec here, and you can see here, they've got it on the fourth line here. They've got their reactivity series written down here. So what I did was I created this based on the AQA spec. That doesn't mean there's not other elements in there. There's other elements such as silver and gold. You might have seen that in there, depending on what textbook you're looking at. Under copper, you would have silver. Under silver, you would have gold. Those are the least reactive elements. The most reactive elements we have are potassium, sodium, and lithium. Is there a participation prize? There is no participation prize, but there is a first and second place prize. So remember, if you want to be part of that and you want to get a prize, then you need to be in this chat. You need to be participating in the revision session. So you can't just say something right at the end. We've had someone try to claim a prize when they only started chatting once the quiz started, and they weren't really participating in the chat, so we couldn't give them the prize. So remember, participate in the chat, try and answer the questions. We want you guys to revise. That's the whole aim of this. We're trying to give you prizes for revising. So we're really trying to encourage that there. So yeah, it's good to memorize this reactivity series. So most reactive potassium, you got copper here. We've got carbon and hydrogen. They're purple. We're going to look at why carbon is purple. They're both non-metals. Hydrogen, that's more important for electrolysis. The reason that's purple there, why that's there. But it's the metals that we're most concerned with here. So the more reactive an element is, the more vigorous its reaction is going to be. And we can see that here. So I've got all of those elements, all the metals anyway, in order of reactivity. And you can see what happens when they react with water. You can see the one at the top is the most violent. Potassium is like explosive with water. If you put potassium in water, it catches fire. It produces a lilac flame. It melts into a ball and then it pops at the end. Very violent. Imagine that with just water. Whereas if you go all the way down with copper, there's no reaction at all with water. So you need to know what happens roughly with the reaction with water and also with acid as well. So again, potassium is the one that's the most violent and copper is the one that's least reactive here. You're making flashcards, so I can't really participate. That's okay, but you're participating right now. Just answer some of my questions. I know you come here and you participate, Roy Akbari. We see your name there all the time, so I'm pretty sure you'll be okay to win a prize if you get first or second. TKD says, I really like this topic. It's been a long time I haven't revised it. Well, perfect time for me to go through this. Okay, so like I said, you need to know how the reactions are, which ones are going to react more violently than others. You want to zoom in? I'm zoomed in a little bit more here, but I'm going to move from this very quickly. So does anyone have any memory tricks that they use to remember the reactivity series? Because I know there's loads around. Just interested to hear what you guys have learned in school. Oh, zoom out, my bad. Here's that. So this is for paper one. If you're AQA, this is for paper one. Yes. This is in the fourth topic. So with the reaction with water, you do need to know roughly what gets produced as well. So we can see that here, we've got the reactions here. If you react a metal with water, you form a metal hydroxide plus hydrogen here. And we've got an example for the group 1 metals. So anything in group 1, we've got an example of their chemical reaction and an example for the group 2 elements as well. So you can see here for potassium plus water forms potassium hydroxide plus hydrogen. Here we go. TKD's got a memory trick. Mass intel cause solution. Is that a memory trick? Please send Charlie mass. Okay, whatever works for you. Ashton says he memorizes it as it is. Fair enough. Yep. There's loads out there. And some of them have more elements than you need to know. Oh, you memorized where carbon is. Okay, cool. So with acids, slightly different. So metal plus acid forms metal salt plus hydrogen. The type of salt forms depends on the type of acid. So if you use hydrochloric acid, that forms a chloride. If you use sulfuric acid, that forms a sulfate. If you use nitric acid, that forms a nitrate. And it's always going to form hydrogen with that as well. So that's that topic done. So like I said, once you've completed that, you can move on to questions. You can try out some exam questions on this. So you can see here, what is the order of decreasing reactivity for these metals? So this is literally an exam question that came up a few years ago. So you can try this out. And once you've tried them out, you can check the mark scheme and see whether you got it right or not. You can also try different quizzes. So here we can try a quiz with 10 questions, random 10 questions from the topic. The spec point is probably the most useful thing here at the end of your revision, because it's like a good checklist to make sure that you learn everything. And then we've got our flashcards at the end. Which metal reacts with an acid to form hydrogen gas? So iron is an example of a metal. So once you know one, you can basically put it as no, or put it as still learning if you don't know what it is. Which metal would you expect not to react with water at all? Copper. Remember, that's the one that's the least reactive in the reactivity series. But you could put others as well, like gold and silver, even though they're not in the list. Okay. So once you're done with that, once you're happy with the topic, you mark it as complete and it turns green, and then your percentage goes up. So you can see here, reactivity of metals is about a third of the way through, and overall completion is 5%, but that will go up every time you check a topic. Okay, so let's move on to extraction of metals. So most metals, so all the metals that we have in everyday life, they're not found naturally as pure metals. They're actually found as metal oxides. So iron, we have iron for loads of different things. We use iron for loads of different things. But where do we get the iron from? We have to mine it, but we don't mine pure iron. Because iron is reactive, it exists as iron oxide. And iron oxide is in rocks. You can find them in rocks. Does anyone know what you call a rock which has the metal in it that you're trying to extract? It's 3 letters. What do you call it? Ores. Yes, they're called ores. So you dig up these ores. Well done, guys. You dig up these ores, and what you're trying to do is you're trying to remove the oxide from it. So remember, you're going to find it as an oxide, so iron oxide, and what you're trying to do is remove the oxygen from it. So we need a specific type of reaction here. So I'm going to introduce you to 2 types of reaction here. We've got oxidation and reduction. So there's 2 ways you can learn their definition: in terms of oxygen or in terms of electrons. In terms of oxygen, oxidation means the gain of oxygen, but reduction means the loss of oxygen. But if you're trying to define it in terms of electrons, oxidation is the loss of electrons and reduction is the gain of electrons. So memorize that. Some people use oil rig to remember that, but that one only helps you to memorize the bottom bit in terms of electrons. So oil rig is good for electrolysis, because that's all to do with electrons. So that helps you remember that oxidation is the loss and reduction is the gain. But remember, this one is only for oxygen in terms of electrons, for electrons. So whenever you're defining in terms of electrons, because if it's in terms of oxygen, it's the other way around. So oxidation, when the metal reacts with oxygen, that's an example of oxidation. So copper plus oxygen forms copper oxide. That's an example of oxidation. But what we're trying to do to those ore, remember, they're already in the form of an oxide. So I was talking about iron oxide. Imagine you had an ore of copper oxide. You want to remove the oxygen from it. You want the loss of oxygen. So what you want is a reduction reaction. So what you want to do to extract a metal out of its ore is a reduction reaction. So for copper oxide, for example, you want to remove the oxygen to form copper. Thank you. Yes, we got to 10K subs, guys, last week. We're really happy about it, and that's all because of you guys. These lives helped us grow our subscribers really quickly the last 2 months that we've been doing it. So thank you for you guys for attending the lives and be active, and for those of you who like comment and like all our posts as well. Couldn't have done it without you. So thank you, guys. So reduction. How do you reduce an ore? You use copper. So if you don't use copper, sorry, you use carbon. So if you react a carbon with oxygen, you get carbon dioxide. So imagine you've got copper oxide. So you've got a copper bonded to oxygen. So what you do here is you react it with carbon. You react this ore with carbon. And what carbon does is it removes the oxygen from the copper oxide. So essentially, this is what happens. This goes over here. And what you get formed is carbon dioxide. And you're left with pure copper here. Now, the only reason this works is because the oxygen gets taken away because carbon is more reactive than copper. So carbon is more reactive than copper. So what that does is it removes the oxygen. The oxygen would rather be bonded to carbon and react with that. So that's why it takes the oxygen away from the copper. If you had a metal which was less reactive than carbon, sorry, more reactive than carbon, then it would not work. So you see it here. This is why it's useful to know the reactivity series. Below carbon, we've got zinc, iron, and copper metals. So all of those would be able to be extracted with reduction. So if you had copper, if you had zinc here, or if you had iron here, you would be able to take the oxygen away to reduce the ore by using carbon. But you can't do that with any of these ones above, magnesium, calcium, lithium, because imagine if you had, let's say we had magnesium here. This magnesium is more reactive than carbon. Therefore, the oxygen will just stay bonded to the magnesium. And the magnesium oxide will stay as it is. The reduction will not happen. So remember this, guys. Only the elements below carbon can be extracted using reduction. The elements above carbon, they need something a bit more powerful. Does anyone know the process that you need to extract an element that's more reactive than carbon? Because the carbon is not going to remove the oxygen, it's not going to reduce it. What do we need? Exactly. You need a process called electrolysis. Well done, Debbie. Well done, Ashton, Roy Akbari, Shadow. Yes, you all got it. Well done, guys. So, electrolysis. We don't want to use electrolysis, though. Why can't we just use electrolysis for all of these? Why do you think we would rather use reduction? Like for zinc, iron, and copper, we could use electrolysis if we really wanted to. I would think it would make things much simpler. Exactly. It's too expensive. Electrolysis, it's in the name, uses electricity, and electricity is very expensive. So it's not the ideal way to do it. But if you do have an element that's more reactive than carbon, then you use electrolysis. You have some elements which are so unreactive, you don't even need extraction. So gold and silver. Remember I talked about gold and silver? They're below copper in the reactivity series. Those are so unreactive that they're found as they are. Gold, you don't get gold oxide because gold is not reactive at all. You can just mine gold as it is. So let's mark that as complete as well. Now, next up, oxidation and reduction. So we've talked about oxidation and reduction. We talked about oil rig. We don't really need to talk about this for the quiz, but take a look at this in the notes, guys, when you're revising this. This is all about writing redox half equations. And those of you who are in FRL classes, we had a whole lesson on this as well. This takes a while. Writing half equations is a bit confusing. So definitely look through this, but it's not going to be part of the quiz, so I won't go through it today. Next, we're going to talk about the acids section of today's quiz. Someone said, does electrolysis require specialist equipment? Specialist equipment? Well, it needs this stuff basically. It needs a battery, electrodes, an electrolyte, and a beaker. This is what it is. And there's a whole topic on this. We're not going through this today, but that's the equipment that you need. What do you mean is too expensive, Sammy? Basically, using electrolysis uses electricity, right? Electricity isn't free. It uses a lot of electricity. And that's much more expensive than just reacting it with carbon and heating it up. Your electricity bills are going to go really high. So people would rather not use electrolysis for it. Yeah, exactly. Exactly what TKD said. Right. Let me put it back onto the Kahoot screen for a second. So give you guys another chance to join. We got 4 people here. Remember, the top 2 will get a prize. So the code is 766 We'll be starting in about 10 minutes. 10 minutes. So get your name in there. We've got Invincible Lark, Golden Crane, Innovative Gazelle, Expert Quail. Is the only solution electrolysis? It's not the only solution. It's the most viable solution. There are other techniques, but by far the easiest one to do is electrolysis. It's expensive. It's expensive, but it's easy to do. What does effervescence mean? Good question. That just means bubbling. Whenever a reaction has effervescence in it, it just means it's bubbling and giving off gas. Debashri, good to see you back on your original account. Yes, exactly. Right. We've got 7 people in there. 2 in 7 chance right now of getting a prize. I'm sure that number will go up in a second. So let's go through pH and neutralization. So pH measures how acidic or alkali something is. So you have the pH scale, which goes from 0 to 14. The lower the number, the more acidic it is. Look at this. Around 1 to 6 or 0 to 6 gives you an acidic solution. Around 0 to 3, I would say is very acidic. 3 to 6 is slightly acidic. 7 is neutral. Then 8 to about 10, oh, I'd say 8 to about 11 is slightly alkali. And then 12 to 14 is very alkali. These colors are not there by chance as well. You can show how acidic or alkali something is by using an indicator. So if you have a solution of an acid or an alkali, you can add a few drops of indicator and it will change color. The color it changes tells you roughly what pH it has. So if we had something very acidic, like hydrochloric acid, it would turn red. If we had something neutral like water or milk, it will be green. And if it's alkali, it will go blue/purple. So from the color, you can predict what pH it is. So that's a good way of estimating it. But if you need to know a very accurate way of finding the pH of something, you can use a pH meter and a pH probe, which you can see here. It's just got this little probe that you put into the solution and it'll give you a digital reading. So it will tell you exactly the pH. So you see here it says it's 7.05. Whereas here, we would just see a green color and we would have to judge it ourselves. It's very subjective. We would have to guess the pH. This is a much more precise way of measuring the pH. Another one is methyl orange. Yes, it is. But that's used in titrations, TKD. It's not used for estimating the pH because that only changes like 2 colors. So you'd use that in the titration, but you won't use it as a way of finding the pH. What is the definition of an acid and an alkali? So an acid releases hydrogen ions, H plus ions in solution. If you get an acid and you add it to water, it will release H plus ions. An alkali will release something else. It will release hydroxide ions, which are OH minus ions. And neutral solutions just have a pH of 7. They have an exactly balanced number of H plus and OH minus ions. Is phenolphthalein an indicator too? Yes, it is. But again, like methyl orange, you can't use it to predict the pH. Okay, so those things that you guys have just listed, the methyl orange and the phenolphthalein, those are called narrow range indicators. Those are used in titrations. You only need to know about titrations if you do triple science. What I'm talking about here is universal indicator. Universal indicator is an example of a wide range indicator. That's because it gives a big variety of colors, so you can estimate the pH. With phenolphthalein and methyl orange, you can't estimate the pH. You can only say, yep, that's an acid. Yes, that's an alkali, but you can't estimate what pH it is. Is an alkali also a water insoluble base? Yes, it is, Dennis. That's good. A base is something, is the opposite of an acid. An alkali is a soluble base. Yeah. So they're basically the same thing. For GCSEs, you can think of them as the same thing. For A levels, there's a bit more to it. Anyone think of doing chemistry A levels? Interesting to hear. It's pretty tricky. But anyone think of doing A level chemistry? Yes, says Deborah Shree. Good to hear. Good to hear. It is a big step up from all of this. Mariam says yes as well. TKD says I really want to do it. Yeah, you probably need to get what, a 6, maybe a 6 or 7 in your school. It depends on your school, but yeah, to do A level, you need to get a certain grade, right? Roy Akbari says I want to do bio and chem. Interesting. That's good. That's good. Maybe going down the medicine route. I'm not sure. AKR says I want to do physics, but it's very hard. It is very hard. I teach biology. I teach chemistry and physics A level, and I must say, is a big step up. So if you get good grades this year in your GCSEs, then you'll probably be okay. I do recommend it for people who get 7s, 8s, 9s to do it. But I have seen people getting lower grades in GCSEs and still doing it A levels as well. So it's all about how hard you work and how hard you try. What did I do for A levels? I did chemistry, physics, maths. Chemistry, physics, maths. That's what I did. Shadow says, I'd like to thank you for your videos. You were able to get 8.7 in your combined science marks. Amazing, Shadow. Well done. Those are great grades. Hopefully you can get even better in your actual exams, but 8.7 is solid marks. Well done. You want to do biology, but I want to be a primary teacher, so no point. If you want to be a primary teacher, yeah, you don't need it, but it's still good to do. It's still a good subject. It's one of those wide range subjects. Roy Akbari wants to do dentistry. Yes, so chem and bio are really good for dentistry as well. Chem, physics, and maths. Yes. Was it hard? Yes. They were hard. They were a step up, guys. I'm not gonna lie. Maths, I was always good at maths, so I found maths okay. I always got like the highest grades in GCSE maths, and then A levels, I found it okay. Physics, because I was good at maths, I found physics okay. Chemistry, I'm not gonna lie, I found it quite tricky back then. Now I find it really easy, chemistry A level. But when I did it for the first time, it was quite tricky. You have to stay on top of it. You can't do the same as what you do for your GCSEs. You can't just leave it to the last minute and revise. For A levels, you have to go from the very beginning, from September. Enjoy it? Yeah, I enjoyed it. They were good. They were interesting subjects. I like subjects where there's a lot of problem solving. So those 3 subjects were good. All right. Reaction. Let's go back to this. So neutralization reaction. A neutralization reaction is when you get an acid and you get an alkali, you react them together and you form a salt and water. There's an ionic equation you need to know for this. So remember, for acids, I said release H plus ions, and alkalis release OH minus ions. If you join them together, you get H2O, you get water. and that's the ionic equation for any neutralization reaction. It doesn't matter what acid and what alkali you use. If you have a neutralization reaction and you get a question asking you to write down the ionic equation, that's what you need to write, exactly what we've got there. And then the last bit we're going to talk about is the differences between strong and weak acids. Okay, so remember what acids do. Acids release H plus ions in water. How did they do that? They do something called ionize. So they ionize in water. So see here, we got hydrochloric acid, HCl. When you add that to water, it breaks up into its ions. It breaks up into H plus ions and Cl minus ions. So in your solution, you've got H plus and Cl minus just floating around there. So strong acids, they fully ionize in water. So what that means is if you had, let's say, a beaker of 1,000, or let's say 100 HCl molecules, okay? Let's say we had a beaker of hydrochloric acid, 100 HCl molecules. It's a strong acid. HCl, hydrochloric acid, is a strong acid, and it fully ionizes. That means every single molecule, all 100 molecules, will break up into those ions, into H plus and Cl minus ions. Weak acids don't do that. Weak acids, we say, partially ionize in water. That means if you had 100 molecules, maybe only 10 of them will ionize. The rest of them will stay whole. So that's the difference between the two. So most of the acids you guys probably know about, they're all strong acids. So hydrochloric acid, nitric acid, sulfuric acid, they're all strong acids. They fully ionize. And here are the equations for them. That means all of the acid breaks up into the ions. Could you also say complete dissociation? Yes. Instead of ionize, you can use the word dissociate as well. That's more of an A-level term. In the spec, if you look at the spec, it says ionize, which is why the notes say ionize. Let me show you in the spec here. Look, there we go. A strong acid is completely ionized in aqueous solution. We've got example here. A weak acid is partially ionized in aqueous solutions. And we've got examples here. So strong acids, hydrochloric, nitric acid, sulfuric acid are all strong acids, and weak acids are ethanoic, citric, and carbonic acids. So strong acids generally have a lower pH because they're more acidic. Weak acids have a higher pH. And then the very last thing we need to talk about is the relationship between pH and H plus ion concentration. So it's this part here. If you increase the H plus concentration by a factor of 10 times, the pH will decrease by 1. So let's say, let me draw a diagram here. Let's say we got a sample of hydrochloric acid and it has a pH of 2. Okay. And let's say the concentration is, let me make up a number. Let's say 1.2 moles per dm cubed. Okay, that's the unit for concentration, 1.2 mole per dm cubed. Now, what I want to do is I want to dilute it. So I add water to it. And now what happens is when I dilute it, its concentration goes to 0.12 moles per dm cubed. How many times has the concentration decreased by, guys? To go from 1.2 to 0.12, how many times have we decreased it? What do you need to divide by to get to this number? To get from 1.2 to 0.1, yes, there we go. We want to divide by 10. Okay. Okay, so we're going to divide by 10. Okay. And then another time, I'm going to say I want to make it more concentrated. So I increase it to 12 moles per dm cubed. I make it more concentrated. How do you get from 1.2 to 12? We make it 10 times more concentrated. So the rule here, so look at this screen here now. The rule says if you increase the H plus ion concentration, so the concentration of the acid, I'm going to put H plus concentration here, by 10 times, by a factor of 10, the pH will decrease by 1. So what you can do here is you can predict the pH based on how much the concentration has changed by. So because this has gone up by 10, according to our rule, the pH will decrease by 1. Okay, it says it will decrease by 1. So what would the pH here be? What do you guys think the pH here would be? It says if you increase the concentration by times 10, the pH will decrease by 1. Exactly. Well done, guys. We got it there. The pH is going to be 1 because times by 10 decreases it by 1. What about below? What's it going to be below? If I decrease the concentration by a factor of 10, what would this pH be? It's going to be 3. You guys are getting it. Well done. The pH here would be 3. This is something people get confused with all the time because you're multiplying one thing and then you're adding the other side. Well, you're minusing the other side. So from this, you can basically work out the pH of anything, really. Let's say it goes to 0.012. What do you guys think the pH here would be? We're basically dividing it by 100 this time. The pH here will be 4. Yes, it will be less acidic, so the pH will go higher. pH would be 4. So from this, you should be able to predict what the pH will be. All right. I hope that made sense, guys. We went through this much more in the FRL classes lesson that we had on this. So remember, guys, we do FRL classes where we go through these topics in much more detail on Fridays and on Sundays. So definitely join that if you guys want some extra revision. 3 times a week, we got chemistry on Fridays, and then we got biology and physics on Sundays. 1 hour. Each session is 1 hour. So yeah, definitely look into that, guys. And now it's time for the quiz. We've got 8 people. That is so low. Let's see what we can get that up to, guys. We got 21 people in the chat. We had 24 people in the chat. Let's see if we can get this number up. And let me just remind you of the rules. If you want to win a prize, you need to have participated in that revision session that we just had, subscribe to us, and be in the top 2. First place, guys, you would win £25 Amazon voucher, and second place would win £5 Amazon voucher. We've got a question here, just a quick question. When do you think A-level will be out? We're working on A-level. I'm not sure. It's taking a while to make A-level content. There's so much of it. You guys won't believe how much content there is compared to GCSE A-level content. There's so much more. But we are working to have. We're trying to have that onto the website as soon as possible. So we got, what is that? RM just joined your Funky Panther. We've got Crafty Eagle. Yes, doesn't matter if you join now. It just means you can't get the prize, but you can still take part. Remember, it's all about the revision. We're trying to get you guys as high of a grade as possible in summer. We've got 15 people in here, guys. Am I waiting for anyone else, or shall I start? What do you guys think? Hassan, you're the fox. Okay. First question's a poll. As usual. Yes, it is. One day I think I forgot to put a poll and we went straight in. I am pretty sure we have a poll in the first question. Let's start. Potato Cos says start. Okay. Let's see. Good luck, guys. First question is a poll. Please tell me it's a poll. Yes, we got a poll. Okay. Whew. How many hours do you revise a day? Interesting to hear that, guys. Just finished half term. I just want to know how much revision you guys are doing. Have you started your revision? Interested to hear. Maybe you guys can get an idea of how everyone else is doing. Maybe it could give you guys a push to do a bit more revision. Remember, not long left now. We've got about, 10 weeks? 10 weeks to GCSEs. Look at that. Wow. 2 to 3 hours is a solid amount of time for revision, guys. So that is good. If you are 6% haven't started. I would think about starting soon, guys. It's just you got so many subjects to learn. It's not just science, you got all those subjects to learn. At least start making some notes. Because that time's gonna once you start the exams, honestly, time flies by and you'll feel like you're just like trying to catch up. So it's better if you get some revision done now. 6% said they do 4 hours plus. Wow, that is an incredible amount. Keep it up, guys. Remember, you get an extra long summer holiday this year. After your year 11, you get what, 2.5 months? That's a ridiculously long time for a summer holidays. So if you work hard now, it will be worth it. I know it seems like you want to rest, you don't want to revise too much, but you have all that time after to chill. So try and revise as much as you can now because you got a really long summer holiday. All right, let's go, guys. First question. Good luck. Slider. Starting off with a slider. What's the pH of water? What is the pH of water? Easy. Slide it to the number. We're getting answers. If I see anyone with 1,000 points here, I'm going to be very suspicious. Very suspicious. pH of water. We've got... There we go. We've got most of the people with the right answer. We've got a few wrong answers here. Water, guys, is neutral. pH is 7. There we go. That was meant to be an easy warm-up question. 16 of you got that. Well done for those of you who got that. Let's see what that does to the numbers. No one got 1,000, but we've got Clever Gazelle there at 991. That was fast moving with your fingers. Ashton, you're first again. All right, let's see if you can stay up there. Next question, quiz. What is the characteristic of strong acids? What do you guys think? Have a high pH, partially ionized, fully ionized, or do not ionize? Which of these do you think is the correct answer? Don't get sucked into the trick. There's a trick answer in there. 5 of you failed for that. They have a high pH. They don't. Strong acids have a very, very low pH. They've got a pH of like 0, 1, or 2. Did anyone fall for that trap? Unlucky if you did. The definition of a strong acid: they fully ionize. Well done, TKD. Yeah, the slider can be a bit tricky. I tried to mix up the questions. We've got a new leader. We got Diligent Zebra. Clever Gazelle's dropped to second. Funky Panther, I think that was someone in the chat, right? Has gone to third place. How many questions? I think 14 or 15. Let's go. Question 4. Question 4. What pH are weak alkalis? This is a pin question again. Move the pin to where you think the weak alkalis will be. I said weak, not strong alkalis. I said weak alkalis. So make sure you pick a number which represents weak alkalis. Oh, we got mixed there. So many people. Oh no. So many people put 4 to 6 there. That's acids. Alkalis are from, there we go, from 8 to around 11. If you put 12, 13, 14, that's a strong alkali. And those of you picked 4, 5, 6, that is a weak acid. At least no one put a strong acid. No one put 0 to 3, and no one put 7, which is good. But that was a 50-50 split. Let's see how that goes. I think that's going to shake things up. We've got Clever Gazelle back on top again. We've got Power Cat and Innovative Gazelle in the top 5. I think this is quite a hard quiz, guys. Some of the questions are going to be a bit tricky. But remember, it's all about learning from your mistakes. Every time you do these quizzes, I'm sure you're learning stuff from your mistakes. So just get through the end of it, even if you don't think you're going to get first place or second place, even 10th place. At least you gain something, right? These are quick quizzes. About 15 minutes left. Right, let's go on to the next question, guys. 5 of 16. Which metal reacts explosively with water? Out of these ones, which one would you say reacts explosively? Potassium, copper, iron, or zinc. Remember, I told you one of these, they burn with a lilac flame and explode. Yes, not copper. Copper is the least reactive. That doesn't react at all with water. Iron reacts a bit with water, but not a lot. It's potassium. That's the one that sets a fire. It's got a lilac flame to it. We still got Clever Gazelle up there. And we've got Diligent Zebra close second, only 3 separating it there. Funky Panther is third and Power Cat is fourth. Are you going to move to TikTok lives? We are thinking about it. Might do soon. I was thinking about doing it today, but I did it in the end. But let's see. Let's see how things go. All right. Are we ready for the next question? Question 6 of 16. Which process involves the gain of oxygen? Gain of oxygen. It's in the name. Is it extraction, electrolysis, oxidation, or reduction? TKD says YouTube is better. It is. It's easier to stream on YouTube. I'm not going to lie. And the screen's bigger. I think like if people are watching on their phones, it's going to be hard for me to write and to have the quiz and to have the website all on your phone. It's going to be hard to see. So I do like YouTube better. But our account is the biggest on TikTok by far. We've got 145K followers there. So we got a big following on that. So I'm sure we'll get bigger quizzes there. Oxidation. Yes, the answer is oxidation. Reduction is the gain of electrons, not of oxygen. It's the loss of oxygen. Remember the differences between the two. I went through that earlier. Next, let's see what the table is saying. We got a change again. Wow, top 2 are really close. Only 4 with between it now. Diligent Zebra is first place. Clever Gazelle is 4 points behind. Funky Panther is a bit further, but still very easy to catch up. Remember, was it last week where we had one question where almost everyone got it wrong, but one person got it right, and then they just suddenly shot up to first place? So you never know what could happen. How many questions? We've got 16 questions. I think we're on question 7 now. Which of these metals do not react with water? I told you earlier. Look at those quick answers. Is it lithium, copper, sodium, or magnesium? I told you about 5 minutes ago. 5 minutes ago, I told you what the answer was for this one. It's the one that's the lowest on the reactivity series out of these ones. Well done, guys. Copper, definitely not lithium. Lithium is a group 1 element. It's very reactive. Not magnesium either. That's quite higher up. It's copper. Let's see what that does to the leaderboard. Leaderboard is the same. Diligent Zebra's gone a bit further than Clever Gazelle. 7-point gap now. Let's go. Next question. Question 8. Pin the answer. Which of these metals need to be extracted with electrolysis? Remember what I said. Any of these. Pick any that needs to be extracted with electrolysis. We've got the whole reactivity series here. So some of these need to be extracted with electrolysis. Some of these can be used, can be extracted using reduction. Which one is it going to be? Ashton's. Oh no, Ashton's phone's bugged out. Unlucky, unlucky. Anything above carbon, guys. Carbon can't be extracted. It's not a metal. The ones above carbon, 13 of you got that right. It's the ones that can't be reduced with carbon. So all the ones below carbon, so the iron, the zinc, the copper, can be reduced because you can remove the oxygen from it. But for electrolysis, that needs to be used for the elements that are more reactive than carbon. We need more harder questions, says Dennis. Ashton, unlucky. Well, Ashton was second. That means second place is up for grabs. Unlucky, Ashton. Maybe you can make it back here. Mirthful Crow, is that anyone in the chat? Diligent Zebra, is that anyone in the chat? Miles ahead now, 400 ahead. Diligent Zebra. Debashri is 5th and Ashton's 4th now. Oh, you didn't drop too much, to be fair. Harder questions. Okay, I'm listening to you. What do the rest of you think? Harder questions, or are these questions okay? I'm going to press next. I don't know if anyone's typing the answer. These are okay, says Debashri. Yeah, I think we need a good mix. We should start off with some easy ones and then maybe get some harder ones at the end. TKD says harder, slightly harder for more competition. Okay. I'll take that on board. Question 19. What forms when metals lose electrons? Ooh, think about this one. If a metal loses an electron, what is it going to form? Is it going to form? Oh, everyone got that right. Amazing. 17 correct answers. Positive ions. When you lose electrons, yes, you get a positive ion. Well done, everyone. Did you get it fast enough? Everyone got it right. So the places are pretty much the same. Brave Barracuda's gone up to 5th place. Question 10 of 16. Which metals require no extraction? Out of these ones, which one doesn't require extraction? Remember, I told you there's some metals which are so unreactive that you don't need to extract it. Exactly. 16 of you got that right. It's gold. You can mine gold. You can find it as it is. Clever Gazelle has moved up to 3rd. Golden Crane has moved up, and Power Cat. They've all been introduced into the top 5. Diligent Zebra is absolutely smashing it, and Mirthful Crow as well, smashing it 2nd place, miles ahead of everyone else. We got a message here. Chemistry and biology is easy. I only struggle with physics. Your videos will help me. Hopefully get more on your next test. Hopefully, yes, 24 out of 56. All right, yeah, you can improve that. Hopefully you can. Good luck. I'm glad to hear my videos are helping. That's good to hear. You haven't done electrolysis yet at school, so you don't have to have done electrolysis for this question. It's a metal extraction question. You just need to know you use electrolysis to extract anything that's more reactive than carbon. And also, I did mention it in the revision session as well. Okay, next question. What are we on? We're on question 11, nearly done. Strong acids have a higher pH than weak acids. True or false? Please don't get caught out here. I've got a feeling people are going to get caught out here. Strong acids have a higher pH than weak acids. Think of the pH scale. If you have a strong acid, is it going to have a higher pH or a lower pH? Oh, 2 of you fell for it. 15 of you got that, read the question properly. If you have a strong acid, it's going to be a lower pH, isn't it? Stronger acids have a pH of 0, 1, or 2. So they're going to be lower. So don't fall for the trick here. Let's see what that does for the table. Table stayed the same. Diligent Zebra right at the top here. Mirthful Crow is 2nd place. Clever Gazelle 3rd place. Okay, let's go to question 12 of 16. True or false? Reduction involves the gain of electrons. Think about it. Think about it. Quick fingers there. That was a quick one. This one you can use oil rig. The answer is true here. Remember, for electrons, you can use oil rig. We got it down here. Oxidation is loss. Reduction is the gain of electrons. For oxygen, you say the opposite. Oxidation is the gain of oxygen. Reduction is the loss of oxygen. Let's see what that does to the table. Table has stayed exactly the same. Top 2 has gone to 10K now, just like we did last week. And then we've got Clever Gazelle at 9,800 as well. We've got 3 more questions. Which ions do acids release? Is it hydrogen? Is it oxygen? Is it hydroxide? Or is it carbonate ions? All acids. Think about what element they have in their chemical symbol. So hydrochloric acid is HCl. Nitric acid is HNO3. Sulfuric acid is H2SO4. They all have H in them. They all release hydrogen ions. When you add them to water, they ionize and they release those hydrogen ions, not hydroxide ions. Hydroxide ions is for alkalites. What do we have? You misread, Ashton. Unlucky, unlucky. Which ions do acids release? Someone says you're at a 9 in physics and bio, but not great at chem, so I need to revise it a lot more. Those are good grades anyway. 9s and 8s are really good. But yeah. Power Cat, we got new third place. We got Power Cat in third place. Mirthful Crow and Diligent Zebra do not look like they're dropping any points here. Well done, you two, whoever you are. Power Cat, Golden Crane, Innovative Gazelle. I don't know who you guys are either. I think I've seen Golden Crane in the chat. Keep going, guys. We've got a few more questions. How many do we have? 3 more questions. This is 14 of 16. What is formed during neutralization? What are those 2 things that get formed during neutralization? Acid and a base, water and salt, hydrogen and oxygen, alkali and acid. Yes, well done. 10 of you got that right. There was a bit of a split there. Neutralization, acid plus alkali forms salt plus water. Remember that, guys. Debashri is Innovative Gazelle. Well done. You're up there. You're up there. Nice. You've moved up to 4th place. Can you get that 2nd or 1st place? You never know. There might be a tricky question at the end there, or something where people need to think a bit more. Let's see. We've got 2 more questions now. Get ready. Puzzle. Okay, this one takes people some time. Rearrange these elements in order of reactivity. Most reactive at the top, guys. Go as fast as you can. We got our first few answers now. People have done it quickly. We got calcium, carbon, gold, potassium. Put the most reactive at the top, least reactive at the bottom. Have you guys been paying attention? That is the question. 11 of you. Wow, that's really good. Potassium is the most reactive. Then we got calcium. Then we've got carbon, and the least reactive one is gold. That does barely reacts with anything. Okay, let's see what that does to the table. Is there any change? Any change? No, it stays exactly the same. Diligent Zebra, Mirthful Crow. We got one last question. Let's see if anyone drops some points here. Good luck, guys. Remember, if you are in the top 2, take a screenshot. Let me put the rules back on. Take a screenshot of your Kahoot character and send it to us. help@flashrevisionlab.com. And yeah, we'll give you guys your... Oh, no. As well as that, you need to send your screenshot of you in the chat as well. And then we'll send you your Amazon voucher. Remember, after this, we'll be live on Friday there. Next for chemistry, we'll be going through... I forgot what we'll be going through, but that's the FRL class. And then we'll be live again on Sunday to go through biology and physics. Go on our website and check it out if you guys do want to join our lives. We got 3 a week. And you can ask me any questions as well. You can email us any questions you have if you're not sure as well. Right, are we ready for the last final question? Let's go. 16 of 16. What happens to pH if the H+ concentration increases by 10 times? Does it decrease by 10, decrease by 1, increase by 1, increase by 10? We've got 12 answers. 12 answers. This is the stuff that we were doing here, like you can see on the screen. What we did right at the end. 10 of you got that right. Well done. It decreases by 1. Remember, this is the rule. If you go up by a factor of 10, so 1.2 to 12, I said the pH goes down by 1. It decreases by 1. Boy, Akbari, well done. You got 2nd. Smashed it. That's your first time winning a prize, right? You've been here since we started, so well done. Send us the screenshot. That's amazing. Let's see who else is on the podium. Debashri saying coming for the top. Well, we've been having people who've been coming every week and they've ended up in the podium. Roy Akbari's been there since the very beginning and finally got onto the podium. So well done. Power Cat, third place. That was close. Mirthful Crow, second place. And Diligent Zebra, well done. You got first place. So, guys, send us your screenshots and we'll reply to you. Rest of you, we'll see you on Friday if you're part of FRL classes. If not, we'll see you on Sunday where we'll do another quiz like this and give out some prizes. Is it possible to go from a 5 to an 8 from now? 100% it's possible. I have seen it happen so many times. People have locked in right at the end and they've managed to smash their exams. I've seen it so many times. Going from a 5 to an 8 is yeah, as long as you change your habits, you change your revision habits. You have to like do like active revision. You can't leave it last minute. And you'll see yourself rise up some grades. No worries. It's a pleasure. We like helping people out. Like I said, we want more people in these lives. The whole aim is to try and get more of the people, more people revising and revising with us, revising with people who know their stuff as well, not just revising on their own. Get some help with the revision as well. You obviously got your school teachers, but you can come home and get some extra revision with us. That's the aim here, with a bit of fun as well. So good seeing you guys. Thank you for being so active on the chat as well. And also thank you for all the likes and all the subscriptions as well. We finally hit 10K. I know that's nothing compared to our TikTok following, but it's still an achievement on YouTube. So yeah. How should I revise for all my sciences? Say Sammy, I would say honestly use our website. Like the notes and exam questions are free. So go through each topic one by one, try out the exam questions, make notes on the notes, try some quiz questions, and use the spec points as like a checklist every time you do a topic or you understand a point on the spec point. Tick it and make sure you know the whole specification. That's the best way to revise. Is it for notes? Is it the notes then questions? I would say, yeah, it's good to do questions once you've done the notes. You should understand the concepts first before trying out exam questions. But you should definitely try out exam questions. When is the next live? So FRL classes, guys, we'll see you on Friday. If you're not FRL class, we'll see you on Sunday. Yeah, most likely on YouTube, but we will let you know. If it is on TikTok, we'll let you know. Keep an eye out on our stories. We'll let you know, but most likely on YouTube. All right, guys. Do we buy gift cards with our own money? Yes, we do. Yes, we do. So it's we do spend quite a lot of money on these prizes. So yeah. 7:30 on Sunday. 7:30 on Sunday. All right, guys. On that note, I'm gonna go and have a bit of a rest. I'll see you guys later this week. Bye.